objectively done. For example, in a zero-knowledge proof, you are proving a computation to a network in a way that the network or anybody can independently verify through computation. They don't have to trust you, what you did. Similarly, you have another situation where a proof of what already happened needs someone to trust you to verify the facts. For example, if you had a documentation and you upload the documentation and you provide a digital signature, then the digital signature is a proof of you owned a document. So it's a proof of what happened, but the verification of the actual data which you provide, the signature,
I'm back.
the verification needs the consensus or whoever is verifying to trust you. So basically from the construction, you see these two parameters of proof of what should happen versus proof of what already happened. And based on that, the verification would be either you can objectively, mathematically verify it, or you need to have a trust source or some kind of trust to verify it.
Yeah, so building on this research and building on how we classify proofs and think about proofs, we've developed what we call this proof of process protocol, and this is where we're able to construct proof chains of different things about statements about reality or held secrets and things like that, and construct chains of proofs where we can convince a verifier of the integrity of a process, right? So it could be like, I'm a business, I'm a marketplace, I'm a supply chain, I'm some kind of consortium with people I don't trust, things like that. I could build a network around this protocol, and I can convince the outside world of the integrity of my business, right, or my operation, or whatever it may be. And in this case, where we can construct the chain built on different types of proofs, where we separate private data from the proofs of the data. We share the proofs of the data in chains, so that the longer the chains are, the more complex chains are, the more rich the proof. So now, building on this implementation, we can analyze the trust models behind it based on the original matrix, and I'll let
So the trust
Anuj
model is
this.
basically a kind of, you can think of as an applied proof matrix. So in the applications perspective, if you see that there are two axes. One is the guarantee, so which is in the first quarter. If you see, it says that, can I guarantee what should happen in the future? For example, in a crowdfunding, in a smart contract, you're trying to say that I can guarantee if so-and-so conditions are met, then like if a certain threshold has been met, then something should happen, like release a fund or something like that. Whereas in the same thing, like in the DAO with 11 curators, you are already saying that I'm guaranteeing what should happen in the future based on certain 11 individuals who have split keys and all the things that can happen. So basically, that's a subjective and a proactive trust model. Whereas when you're having a proof of existence to claim some commitment that you did in the past, so it's a commitment of what already happened in the past, and you're just committing a particular hash or something to a particular transaction, that is a guaranteeing what already happened. And the verification of that, or the assumption that you have basically, is that you can guarantee what happened as long as it could be mathematically or objectively verified. And the last scenario is where something already happened. Like, for example, you can provide a proof that you have a certain criteria that has to be met for a certain discount for insurance. So you collect all the documentation step by step, and you have a cryptographic audit trail. And through the audit trail, which is guaranteeing what already happened, it's an audit trail, you can present it to the network. And if the network subjectively trusts that, for example, the signatures in this case, then it can provide you with whatever it has to provide you. So that would be a guaranteeing what already happened, as long as the assumption is that it can be subjectively verified.
Okay, so applying that model to a network, now we can treat the entire network as a type of proof system, right? And so again, going back to the original idea about Bitcoin, you can imagine that as Bitcoin, but like what we're trying to do today, mixing in different systems, different chains, different legacy systems, and different proof models, we can kind of create this peer-to-peer system where we have different heterogeneous actors and participants on the network and still achieve this prover verifier. The ultimate goal as a means, so this is a means to building a kind of a transition of a paradigm between client-server architecture and prover verifier. As we know, going back to the beginning of the internet, client-server architecture was built on the assumption that we trust everybody on the network. Today's hyper-connected world is much different, conditions are much different, so we're looking to take it to the prover verifier model. So yeah, so thank you. Thank you. I see some faces here from last night. I think we're still recovering from a lot of champagne. So, but thanks for coming out. Hit us up. We're looking for folks to help us build these networks. So thank you.